Welcome back. So far in this course, you learned to read data stream from sources, transform it, and finally write it to the sink. Reading data from streaming sources and writing to a sink is straightforward. In fact, transformations are also straightforward for those who already learned to use data frames. However, stream processing brings some features to simplify our life. In this section and in the next section, we will focus on those new transformation features and their internals. So, let's start. Spark streaming transformations are broadly classified into two categories: stateless transformations and stateful transformations. To understand the difference between these two categories, you must clearly know the answer to the following question. What is the state? Let me explain. We already learned that the Spark structured streaming application runs as a series of micro batches, right? We created an example to calculate customer rewards and sent a notification to the customer. Let's say we have a new customer today. He shopped at one of our stores and you got an invoice. The first micro batch starts and computes his rewards. It looks like this. Now you created a notification record and sent it to the customer. Your first micro batch completes here. However, the micro batch will also push this record to a state store for future reference. Now the customer again comes back to your store the next day. A micro batch will get the invoice and calculate the rewards for the new invoice. The outcome should look like this. What does it mean? The customer shopped for 300, right? But his total purchase is now 800. How? Well, 500 comes from the state store and 300 for today's invoice. Similarly, his reward points is 160. 100 comes from a state store and 60 for the new purchase. Make sense? This new record will go to the sink and it will also update the state store. Why? Because the state of the customer is changed, so it must be updated. Now let's assume the customer comes for the third time and makes another purchase. The new micro batch will compute the rewards, which looks like this. This time he purchased for 800 and we computed his totals again. The new state goes to the sink and it also updates the state store. So, the state store is a necessary part of a stream processing system. Why? Because the aggregations are not possible if you do not know the past result. We do not need all the history, but you need the most recent state for the same customer. Otherwise, you cannot compute the totals. Make sense? We have already implemented this example. Let me show you the code. Here it is. I am taking a sum of the total value and it works. But how does it work? If you notice, we are writing code to calculate the sum for the current batch only. But Spark API automatically computes the sum across the batches. We do not need to code for it. Spark Streaming API takes care of it with the help of a state store. Great. Now that you understand the meaning and need for the state information, let's come back to understand the difference between two categories of transformations. All the projection transformations such as select, filter, map, flat map, explode, etc. are the stateless transformations because they do not need to maintain a state across the micro batches. These operations will always work with the current micro batch and they have nothing to do with the history. The grouping and aggregation transformations are stateful transformations because they need to maintain states across the micro batches. The grouping and aggregation cannot work correctly without knowing the history, so they always rely on the state information. Great. Hope you understand the difference now. States are essential and mandatory things for aggregations and join to work. However, we also have some side effects of these states. Let me explain. A streaming query having only stateless transformations will not support the complete output mode. So, you can only use append or update modes. The question is, why? We have a straightforward reason. Stateless queries will produce one or more records for each input record. For example, select and map transformations are one-to-one conversions. You have 10 records in the input data frame, you will get 10 in the output data frame, right? Therefore, remembering the outcome of the stateless queries are not efficient. Hence, Spark does not remember the previous outcomes and it does not maintain the state for such transformations. So, Spark cannot give complete output for every micro batch. Simple, right? Now let's come to the second side effect. An excessive amount of state may cause you memory problems. Again, the next question is why? Because the state is maintained in the memory of the Spark executors. It is also backed up and checkpointed to the checkpoint location. However, the checkpointed state is used for reloading the state after the failure or restart. But at runtime, the state is cached in the executor memory. For this reason, state management is one of the critical design considerations. If you do not maintain the state properly and allow it to grow forever, you will run out of the memory at some point. Therefore, Spark offers you two types of stateful operations: managed stateful operations and unmanaged stateful operations. All stateful operations are classified into the first category, where the Spark manages intermediate state and its life cycle. Spark will automatically clean the state entries when they are no longer needed. This cleaning is critical to keep the size of the state store in control. Whereas the unmanaged stateful operations are more flexible and they allow you to define your own custom state cleanup logic. However, unmanaged stateful operations are evolving and they are only available in Scala and Java language. As of Spark 3.0, unmanaged stateful operations are not available to PySpark. You will learn more about the implementation details of the stateful operations as you progress with the course. However, you might be wondering when to use managed and when to use unmanaged stateful operations. Let me explain. Aggregations are of two types: continuous aggregations and time-bound aggregations. Let's try to understand them considering the loyalty calculation example. In the loyalty calculation use case, we read invoices to compute the loyalty point for the customer. When we get a new invoice for the same customer, we add loyalty points to the previous value. If we get a new customer, we create a new entry, and this keeps going on forever. We do not have an end to this. Now consider you got 1 million unique customers in a few months. So you will need to hold 1 million state entries in the executor memory. Now the next question is this: how long we keep the state for a customer? Many of your customers might not be active for a long time. Do you want to keep the state in memory? In fact, there is no way for Spark to know if the customer is now inactive for a long time and his state should be cleaned. By default, all the stateful operations are managed by Spark. So this state is also managed by the Spark. The loyalty aggregation is an ever-growing continuous aggregation, and hence Spark will never clean the state. It doesn't even know when to clean the customer record. So this use case should be the right candidate to implement using unmanaged stateful operation where you can define a custom cleanup logic. Now let me modify the loyalty requirement. Let's consider the loyalty points are accumulated weekly. So customers can shop from your stores and collect loyalty points, but these loyalty points will accumulate only for 7 days. After 7 days, the total accumulated points will be posted in a loyalty account for customers to redeem. That's all, you are done for the week. Next week, computation again restarts from 0 and you can again accumulate it for next 7 days. This goes on in a weekly cycle. Such aggregations are time-bound aggregations. In this case, your state is only valid for a week. So, Spark can clean the state for the previous week and start again for the new week. The point is straight. All time-bound aggregations are the right candidate for Spark to manage the state cleanup. However, if you are going for a continuous aggregation, you should consider applying a custom cleanup logic. Make sense? Great. Let me summarize the takeaways of this video. Spark structured streaming offers you two types of transformations: stateless transformation and stateful transformation. Stateless transformations do not support complete output mode, and we discussed a reason for the same, right? Stateful transformations will store the intermediate state information in the executor memory. So, cleaning the outdated state becomes a critical design decision. Therefore, you should prefer to model your solutions using time-bound states. In the case of time-bound states, Spark will clean the outdated states and you can keep the memory requirement in control. However, if a time-bound state is not an option, you must consider using unmanaged stateful transformation and provide your own cleaning logic. However, unmanaged stateful transformations are only available to Scala and Java APIs. PySpark 3.0 does not provide APIs for implementing unmanaged states. That's all for this video. And we will start learning the mechanics of implementing time-bound stateful transformations from the next video. See you again. Keep learning and keep growing.